Hello everybody, this is Randy, Kilo November 4, Yankee Bravo Alpha. Today I'm going to take my demonstration of the interface in the Ameritron RCS 1012L to USB with my flex radio, and I'm going to take it down a little more details on the actual electronic switch that you'll build in your ham shack to interface with the relay where you have it on your antenna, up in the outside, in your attic like me. But essentially, we're eliminating this control box where you manually got to select your antennas. So I'm going to go through this slides and take you to the actual operation of it, testing of it, and we can test it on the desktop without having the relay box there. Yesterday, I demonstrated it with this, but if you have it already installed, don't want to pull it down, there's a way to demonstrate it without using that, but using the switches of the multimeter. Anyways, moving on. So when I wired mine up, I synchronized all the wiring. For example, USB number 1 normally opens all brown, and it goes to a terminal board. It's an extension for me to give me more growth of what need to, and from there it goes to the electronic switch down here. These are the wires for all the 8 normally open switches, and the over here is the same thing. The normally closed, or the common, the common is got red wire, 12 volts going to that all the time, and all 8 relays. And of course, it normally opens. Whenever you select an antenna, it'll take the 12 volts and it'll take it through that contact, through that relay. And it runs over to the, of course, the terminal board, and then through my electronic switch. Now, the electronic switch has 8 connectors on it for the antennas. It's got a DC negative power. It's got the 3 outputs, A, B, and C, which MSJ uses. Here's a little more detail on the relay to break it out. With the 12 volts, of course, you're going to plug a USB cable into it. Like I said before, I number this. It makes it easier when I looking at it to identify the right relay. This is a common, and this is the normally open for the relay, each one of those. So I put a little dot on it just to make it easier. Electronic switch. This is actually a terminal board. It's actually just an interface. Give me some options. I first connect from the USB to here. Each row represents an antenna. I got 8 rows here. And of course, I got negative power here and then positive power there. I just added this for future growth. And then here's the actual switch, electronic switch. And I incorporated all the diodes. And I'll go back to the drawing real quick and show you that. But incorporated all the diodes and capacitors in this little board. So I've got all 8 coming in. These are inputs, 1 through 8. Got the diodes, got a ground, and then here's your A, B, and C. I got my ground going there. And they got a couple capacitors that I use also. Going back here, here's the drawing. So I'm essentially, I designed or built to this specification here. Now, I don't have antenna switch. I use relays. These are my relays. The 12 volt goes to the common, and there's, depending on which USB antenna I pick, it'll automatically switch and energize that contact. Of course, I got this Slane Smart USB 8-channel relay board from Amazon. Here it says currently unavailable. I'm sure you can find it somewhere. They're all over the web. You need 3 of these capacitors. I bought it from Amazon. And of course, the diodes are important. I use 12 in the circuit itself. Okay, moving on. To the board. A couple things you'll need. You're going to need of course, you need this software, and I got it from the Slane Smart website. You can download the Relay Manager from there, and I use Windows. If you use other software, I can't tell you how to do it, but I'm sure there's a way to do it. Use a standard multimeter. You need a 12 volt DC power supply. I say anything above 1, 1.5 amps, probably 1 amp would be fine. And computer USB ports, and of course a USB cable. So this is kind of how it works, and it's to test it on the bench is all you need. This is right from the MFJ drawing. Essentially what the example is, when you're checking power, you got power on and you select antenna number 1, you will receive no voltages across A, B, or C. You'll go to number 2, you're going to see 12 volts on pin A, but B and C will be 0 volts or less than probably 3. Once you go to antenna 3, there will be no power on terminal A. Terminal B will have 12 volts. Terminal C will be off. And number 4, of course, you'll have 12 volts on terminal A, terminal B, and terminal C. And I don't know if you can see it, but I've identified A, B, and C on this piece of paper when I check the voltage. That way you can see what it's doing. So the first thing I'm going to do is first, let me see if I got my manager. I got the manager up and running. So first thing I'm going to do is apply 12 volts to the USB relay. And you can see maybe there's power is lit up. And the next thing I'm going to do is, if I can find my cable, is plug in the USB cable to my computer. Okay, you can hear it, and the computer makes some sounds. Now come up here and look, and I'm going to select relay board 1. I'm going to open it up. You get a green up here. Then I go to manual mode. So, for example, let me turn my multimeter on. And yeah, you can see it. I got ground on my black wire. And I'm going to go ahead. I'm on relay number 1. I'll turn it on. So I should get no voltage here, or very little. Yeah, less than 2 volts. Less than 2 volts, which is correct. So I turn that off. I'll go to relay 2. Relay number 2 says I get 12 volts on A, no power on B and C. So let's go to terminal A. I got 16 volts. B, less than 2. C, less than 1. Okay, now turn that off. Let's go to antenna 3. Antenna 3 says no power on A and C, but B should read 12 volts. Let's turn 3 on. It says I should read power on B. Let's go to B. I got 16 volts. Now C and A, hold it there, less than 2 volts. So on and so forth. Let's go to number 4. That's my other example, just to show it. Let me turn off 3. On number 4, I should read A and B should read 12 volts. C has no power. So let's go to A, 16, B, 16, C. And that's great. And that's kind of all this demo was, to show you how to test it out. Like I said, I built this to the spec of MFJ in their drawing package that comes with the antenna selector. I only designed this part of it. I copied this design here with the diodes and capacitors. And it works well. But this will give you the capability of doing a bench check of your circuit before you actually connect it to your antenna relay. And it saves you from having to take the antenna relay out of the attic. So I hope this was beneficial. If you have any questions, you surely can email me at admin@KN4YBA.com. 73s to you, and have a great day.